Hello. So we are back Sunday, yeah, and we are on our living room, on my living room, and it's time for the power supply video, yeah. So if you'll see on the back Diana or the kids, that's normal. The green things from there is Diana green screen for live streaming. She's a gamer and a streamer. So I just try to make you familiar with what will happen here. I don't know what kind of expectation do you have, but this is a video for beginners. So if you are a beginner, I don't think you'll get bored. But if you know more about the power supplies, probably you will get bored. Yeah? But anyway, I'll try to make it short as possible. Okay? Good. Okay, what we will build today? Building, designing, this is beautiful. So before having a job, that's mean like 25 years ago, or more, probably more. So before getting my first job when I was young, that's all I was doing. I was building things. It's so nice. You can build a lot of things. And the way how you can do it quickly, I will show you today. Yeah, we'll do it today. But it's so nice. So if I want right now a power supply, probably I will have it. Like, let's say if I will be to do it for myself, I will have a power supply, a linear power supply, adjustable current and voltage, probably like 5 minutes. Yeah, you will see how. Or if I want an audio amplifier, probably I will have it in 15 minutes. So it's we can do it. And probably I will do it more in the future. So let's start with the basic. So what we have the transformer. You remember we bought the transformer. So I cut the connection and I soldered the main wire, the 220 volts, and on the output I cut down these two wires because I don't need this. This comes with you have a median wire, but we don't need. So we have two voltages. Are not the same? No, are not. So are different. So we'll use only these two wires. Okay, what is this? This is a transformer. Yeah, a linear transformer. A transformer, it is a power supply. Okay, so let's check together. This is a power supply. So if you need, like on this condition, like you need AC, you need 1 voltage, this is a power supply. Okay. I haven't worked for a long time with this one. How can I switch on AC, DC? Yeah, AC. Yeah. So AC, and we have 25 volts. 25 volts is fine. If I will be to build myself a power supply to use, I can't see the need or more than 20 volts. On the laptops you need like 19, 20. On the phones you need even less. I can't see the point to have a power supply over this voltage. But anyway, depends what you have. So you use what you'll have. If you have another transformer with different voltage, this is 3 amps, so my power supply will be like 3 amps. Yeah, 3 amps. Okay, so that's what we will use today. 25 volts should be like 30 volts after the rectifier bridge and the capacitors. So it's fine. We can do a power supply 25 volts. Yeah, something like that. Okay, so we have the transformer. This is a power supply. Already we checked 25 volts AC. Yeah, so if we'll be to draw, that's our transformer. Just short. Yeah, I will not This is the primary. This comes 220 volts AC. Because the transformer is working with AC, doesn't work with DC. You know that already, yeah? And I have the secondary. And that's the output. So I will not use this one. I said I will not use this one. This is too high. It's 35 volts. It will be 40. Based on the fact we'll do a power supply without relay, you know, the input relay to switch the voltage on the input. I will say we are fine with this one. Okay, so on this one we have 25 volts, 25 AC. Okay, so this is a power supply. Now the next step, you know AC, you know what I mean, AC, alternative current. You have AC and DC. DC is just a line, okay? AC, that's the wave shape of the AC. That's the median point where you have 0 volts, and you have on one side here you have plus, on our case 25 volts, and here you have minus 25 volts. Yeah, that's AC. If you want to see exactly, to understand how the AC actually is looking like, yeah, let's try. Maybe I can do it and I can show you. I have few live bulbs here. This will be good. Okay, let's try. Yeah, I have the power supply. Okay, so it is working. Good. So the AC is looking like that. So now I will simulate AC 12 volts, 1 hertz. Yeah, 1 hertz per second. Okay, I can't do it 50 hertz. Yeah, like how much you have on the main. So this will be 1 hertz. Yeah, so this is AC. What do we have here? We have DC. We have plus and minus. Okay, here is DC, 13 volts. You can see on the multimeter. So we have DC, and from DC we will create AC. Okay, so this will be AC 13 volts, 1 hertz per second. Okay, so this is 1 hertz per second, AC. Now 50 hertz per second is very fast, but that's how AC it is. Yeah, it's changing plus or minus. Yeah, this was 1 hertz because it's changing once per second, but on the main power, yeah, on your house, yeah, you have 220, but you have 50 hertz. That means it's changing 50 times per second, but it's too fast. I can't replicate that one, but you got the point how AC is created. So AC basically at DC switching fast. Okay, so you know what, I don't want this to get longer, so let's try. We have my solder iron. I replaced my solder iron, the old one, you know, the cheap one. I think it was 13 pounds. You know, these get broken, you know, the screw, and you know, I said I will buy different one. This is not too much much expensive. I think this was like 25 or 30. It's a Weller Expert 8100 UD. So you can find it on eBay, but this is pretty good. Yeah, so what I will do, we have to change the AC from DC, and you can do it on different way. Let's say how you can do it. Based on the fact it's changing to plus or minus, we can use a diode. A diode rectifier diode. What the diode will do, when the wave is up here plus 25, if the diode is like that, the diode will drive the current. Okay? When it's going down, not. So you can use one diode. Yeah? But with one diode, you will have something like that. With one diode, you have this. You have the line, the DC line, and the diode will pass only this bit. So it'll be something like that. After that is going to the minus, the wave. So it will not drive the current. And after that again, the plus. And will be something like that, your current. In reality, the voltage will be lower. So you'll have like half voltage using one diode. Something like that. Okay? Good. So in order to use this part, which is going up to plus 25 and down to minus 25, we can use a rectifier bridge. But I think you know already, and I will not go because this is, it will get us a lot of time. So I will use a rectifier bridge here. No, no use, no for diodes. That's long. I think I have like 3 amps or 5 amps rectifier bridge. Yeah, I do have all the components I checked before. So we will use something like that. This is a rectifier bridge, but also you can do it with diodes. So let's say you don't have a rectifier bridge. It's okay. You can do it with diodes. So with diodes will be like that. Yeah. So you have AC. You have one diode. Yeah. Will be one diode like that, minus plus of the diode. Okay. You have one diode on the other way. Yeah. So based on this one, when it will be plus, it will be the positive. It will go on this diode. When it will be negative, it will go on this diode. Okay, that's how rectifier bridge is working. Okay, here we have another diode. And on the end, here we have another diode. So what we'll have here, we'll have plus from here, minus, and the AC is coming here and here. Okay, that's how a rectifier bridge looks if you are to do it with diodes, or you can use one which it's it's everything inside. Okay, so let's solder the diodes and check again. Now just be sure your rectifier bridge will carry enough the current. But if you can, if I will be to build a power supply for myself, I need 3 amps, 5 amps, doesn't matter. I will use like a double power rectifier bridge. So in this case, probably I will use like 10 amps rectifier bridge if you want to buy it. If not, use what you have. It's okay. That's my AC. So my AC is coming to my rectifier bridge here and here. Okay. It's okay. You don't need what's the name? The PCB. No. That's long. That's long. It will stop you being creative. Yeah. Actually, it's long. So you build something and you make the board. You solder the components. Oh, I want to change something, or okay, I want to build something else. So building in air is great. It will make your soldering skill fantastic. So AC there, AC here. Okay, this is plugged. I didn't think this is plugged. So AC is solder. Okay, let's check to see if it's working. Maybe the rectifier bridge just died. So we have DC. DC, we have 24 volts, minus plus. Nearly 24 volts, you can see there. After you will use a capacitor, the voltage will goes a little bit up. Okay, so this is our voltage. Now it's AC, it's DC, sorry. Now it's DC, but still, our current right now is like that. It's not like that, but also we have even this, and this, and this. This is our current, yeah? So we have to straight the current. Straight the current with a capacitor. I have my box with ways here. So we will use something like that, okay? Now, the capacitor, pay attention to be the voltage, to be like double, to be safe. So we have like 25 volts, use a 50 volts capacitor, probably not 550, but in our case 63 volts. This is 4700 micro. On the power rail, the capacitors, the rule of the capacitor is like bigger, it's always better, yeah? So try to use highest possible capacity because it will make the current more straight. So let me unplug this time the transformer, and somehow we have to solder the rectifier bridge on the capacitor. Okay, so should be like that's minus. Okay, should be something like that. Plus and minus. I just want to be sure. You can't really do mistakes here. We have no fuse, so probably you should use a fuse. The manufacturer of the transformer is saying the transformer has a thermal fuse inside. That's solder. This is minus is solder. Fantastic. So now we can plug the transformer and we can check the voltage. We can check the voltage now on the capacitor. So on the capacitor right now we have 35 volts. You can see on the multimeter. Okay, but actually it is more complicated, and I should speak about this more. So the voltage, this 35 volts is because the transformer, the capacitor, sorry, it will store even the high spikes of the wave, yeah. But the voltage, actually, what you can use is somewhere here. Okay, so somewhere here, not here, like we have now 35 volts. So here we have 35 volts. This is not really usable, yeah. So usable is somewhere here. on a median point, and what we can use probably is around what we have with the rectifier, with the rectifier bridge without the capacitor at 25 volts. So soon as I will connect a load here, the voltage will goes down. Okay, but we'll see together. The next one. So you see, this is quite solid. You know, it's you can do it without a board, without a what's the name? You know what I mean, yeah. I don't think even I can do it here, because here the problem they have a issue with the acid, and they ban the acid, because obviously you need a board. After that you need the paint to make the tracks, and you have to burn the board on acid. Before I was using I don't remember. I don't know the English name. Nitrate acid. Yeah, I know the chemical HNO3. Yeah, HNO3 is nitric acid. That's what I was using before to burn the board. But you know what? Leave me a comment if you want to do it. I think it's another way. Ferric chloride. Yeah, this is an alternate. Oh, this is on eBay. Yes, so you can do the board. Just leave me a comment if you want to do the board, and we can do the board. Yeah, this is an alternative of the acid, so we can use ferric chloride to burn the. Yeah, just leave me a comment. I will do it. It's okay. Yeah. Good. Next step. So we have plus 35 volts. This is a power supply. Yes, it is. What do we have now? We have plus 35 DC. So if you need a stable voltage, yeah, you have it. But we have to build a power supply. Next, I'll try to be fast because it's a lot. I want to explain exactly how this power supply will work, so you'll understand. When you understand how a thing works, you can modify it. You can do whatever you want. Okay. So we have the capacitor. I haven't drawn the capacitor. This is the plus the capacitor minus. Okay. Next one, let's start with the power supply. We have 35 volts. And the only way to adjust the voltage from plus to minus, down and up, sorry, it's using a transistor. That's the most easy thing, yeah? So you have a transistor. You know the transistor, let's say an NPN transistor. That's the symbol of the transistor. So we have the base, we have the collector, and I have the emitter. If it's an NPN transistor, the arrow will be out. Yeah? How the transistor is working? You see this collector and emitter? Actually here, depends of the transistor capacity, you can connect a load. You can adjust the resistance. Yeah, adjusting the resistance, actually you adjust the current. So the condition of this is like a switch. So this, it's a switch, but it's like a variable switch. Yeah, it's an adjustable switch. Okay, so in order to have here from collector to emitter to pass the current, all what we need a voltage between emitter and collector, and that voltage is around 0.6 volts. 0.6 volts. Actually the transistor is opened by the current, but forget about that. Just keep in mind the transistor is opened by 0.6 volts, like a normal bipolar transistor. So we'll use a transistor. I will use what I have here. I have some transistor. I got them from a audio amplifier. So I have like a pair, and I keep them for, maybe we'll build, so these ones. Okay? So I'll use one of these. One should be enough. Okay? I remember these are PNP, these are NPN. So we'll use an NPN transistor. Hopefully it's good. What transistor is this? This is not even made for a power supply, but it's a transistor. How can I switch to the display? Okay, like that. So this one is because you will ask. That's the one. 32181. Yeah, that's the one. We have like 200 volts collector emitter, which we don't need it anyway. Yeah. And we have 150 watts power dissipation. That means we can have like 5 amps. Yeah, we can. Okay. But use what we have. Or you know what? Look here, recommended for 100 watts high fidelity audio. Because is okay, the base is here. Just keep in mind where is the base collector and emitter. Or we can use something else. We have here or we can use this. I think this is tip. 1 second. Tip 3055. But the problem with this one, okay, we have only 90 watts. So if I will use this, probably I have to use 2, not 1. These are quite cheap. 90 watts. That's the power what this transistor can. It's like the max power. So you have to be always under the max power, because otherwise the transistor will get hot and you will burn the transistor. So if I will have to use this, I will use 2 on a parallel mode. So I will use only one. This one. This is more powerful. So I will use this. I have a heatsink. So keep in mind we are doing here just for the training purposes. But on the real life, you need a 10 times bigger heatsink. Yeah? Or, like how it's in these days power supply, you need a heatsink, not so big, but you must have a fan there. A fan to cool down the. But especially for this kind of power supply where you don't have switches to switch the voltage. Yeah? You know what I mean. So you'll have a lot of heat. So all we'll use this heatsink, which is a small one. This is a small one. The transistor will get hot very quickly when you have a low resistance load. Pay attention on the thing. So if you see here, this is the metal, it's connected to the collector. So you understand, will be voltage on your heatsink. Okay, the transistor is connected. So we have this transistor, we have it here. Okay. Good. So this is a NPN transistor. So we will start drawing our power supply. So this will be connected here. Plus 35 volts. 35 volts. And we will have minus here. Minus. So first what I will do, I will connect that transistor. So that transistor is this one. This will be our collector. This will be our emitter, which will be the output. This will be our base. So it's a NPN, that means the arrow is going outside. Again, this is the collector, this is the emitter, and this is the base. Okay? So, and this is the ground. Okay, let's use two wires and connect. So we have plus 45 to the collector. We can do something more. On this stage, we can connect our voltmeter. So we have an ammeter, which are these two wires, and we have the voltmeter. You remember on the I spoke about this and I said, I bought this because it's volts and amps, and this was like £3, if I remember, 3 or 4 pounds, something like that. Because to build something like that, it's a bit complicated. Okay, so we'll use this. This is a voltmeter and the ammeter. But again, if I will be to build for myself, I will use an analog ammeter and a digital voltmeter. Okay. So let me think first. How can I do it? Okay, let's solder this wire. Let me unplug the transformer. It's still plugged in. Let me solder these two wires. Always when you are build things, keep the wire short. You don't want to have like moving wires, and to avoid doing any short circuit. Always use the open color for plus, for positive. In our case, I will use red for plus and red and black for minus. This is plus. And minus. So I have plus and minus, and I want to connect this voltmeter. And if I remember when I bought it, this is the checking the voltage. This is plus and minus, and I will connect plus and minus with this plus and minus. So here we will have a voltmeter. No, sorry, the voltmeter actually is not here. The voltmeter will be on the output. So here and here we have a voltmeter. V, voltmeter, checking the voltage. But obviously this voltmeter has to have power. So the voltmeter will check the voltage on this wire. So this wire will be soldered on the output. But this need voltage, so it will be here. This is plus. And this is minus. So the transformer is unplugged. Yeah. This is my transformer, and it's still on because the capacitor is holding the charge. Okay, next I said, you know what? I will solder the plus to the collector. So the middle is the collector. So this is plus. The plus should come on the collector. Okay. And now all I want to connect the voltmeter on the emitter, which is the output emitter. This one. I think that's emitter, yeah? Be careful on the pins, yeah? Yes, that's emitter. So this one is emitter. You see, it's nice to build things. And you have a lot of information. On my time, I have to build something. I have to buy a book with schematics. Well, these days with the internet, wow. Okay. Next, we need a load. So we need to have a load. A load on our case can be, we have two, because the voltage is too high, I will use two light bulbs, yeah? And I will connect them on a serial mode. The light bulbs, they don't have plus and minus. Actually, many people see a light bulb as a light bulb. You can see them as resistors, okay? Because obviously the light bulbs, they have a resistance, an internal resistance. So it's okay if you see a light bulb as a resistor. So we have our load. So our load should be connected to ground here. Yes, because the ground, yeah? Let's draw the load. So here should be minus, here should be plus, and the load is here. And we have two light bulbs. And a serial mode. 12 volts each. Because if the voltage goes high, I don't want to burn them. So minus, this is the minus which is coming from the rectifier bridge. The minus is the same. Minus here. And plus on the emitter, which I said is the output. The emitter is the output. So what we have now is this schematic. We have this. We have this. This is what we have. Okay? So let's power up. Let me plug the thingy. We have voltage. The ammeter is not connected, but this is on because we took the power supply for this one from here, which is not draw. But he is checking the voltage here. So here we have 0 volts. That means on the output. So the light bulbs are not on. The only way to make the light bulbs to be on is to, on my base, to be compared with the emitter at 0.6 volts. Yeah. What we can do here, on the collector, we know we have voltage. Yeah. So if I will apply the voltage to the base, that means on the output, I will have minus 0.6 volts. Yeah. So shorting the base with the collector, and my light bulbs are on. And you can see the voltage. Check the voltage. So actually the voltmeter is checking the output voltage. The output voltage, yeah, is clear. So if right now I will check the voltage, the base with the emitter, when it's short with the collector will be like 0.6. But we don't need something like that. We need a adjustable power supply. So we have to adjust the current and the voltage. The easy way to change the voltage is playing with the base. Yeah. One of the main things of the transistor is amplification. It's not like a switch. It's acting like a switch, but also it's amplifying the signals. Yeah, that's the reason why you have here 0.6 volts, but you can play with many amps on the output. Yeah, on the in between collector and emitter. So let's use no. What you can use a big potentiometer. Let me see if I can, if that's the name. Potentiometer. Yeah, that's the name. So you can use something like that. Like a big one, adjustable, yeah? So you can adjust the voltage and the current. I will use a small one, yeah? I don't have the big ones, but it's okay, you know, if you need one on the panel, obviously you have to use a big one so you can adjust it. I'll use a small one and I'll adjust it with the screwdriver, yeah? So we'll use 10 kiloohms, it's 103, yeah? I will use a 10 kiloohm, 10 or 20. Mm-hmm. Ten should be fine. Yeah, 10 kiloohms should be okay. Where's 10 kiloohms? 20, no, 20. 103, yeah, 10 kiloohms. So let's do something like that with our base. No, let's do something else before, yeah? I don't know if you ever heard about Darlington transistors. And actually the people are building transistor, not Darlington. Darlington is the name of one transistor with another transistor here. Yeah, so this transistor, it will open this transistor. So the arrow is out. The collector is together with this collector, and all what we have left is a base here. Yeah, this is the emitter, this is collector, this is base. This is called Darlington mode. So actually this transistor, it's open by this one. So when I will be here to apply voltage on this base, this will get open and it will open my big transistor. Why the people are using this Darlington is because any transistor has amplification. So using two transistors, actually the amplification increase. And my base is very sensible. So let's use another transistor just to make everything more sensible. When it's sensible, yeah, I think that's the name. Sensitive. Anyway, you can use low signals. You can play with low signals on the input, and that's what we want. What do I have here? I have I ordered from eBay BD139. Yeah, it's an NPN transistor. NPN transistor. And I will use this one. On this one, I know for sure it's emitter, collector, base. So collector is with the collector, with this middle. Emitter, it's with the base, yeah? So let's use this one. Let's solder this one first. Let me unplug it. But obviously use what you have. If you have different transistor, use different transistor. This is base. This is collector. Yeah. Yeah. So we solder the transistor over this big one. Emitter of this one on the base of this one. Yeah. Collector with collector, and we have a base. Now, the amplification is very high, so I should be able to open this with low signals. And low signals meaning my hand doesn't work like that. Let's try like that. So you see, I'm using the finger on the plus, or anyway this plus, and base, yeah, here. So you see, now it's very sensible. Of course the body has a resistance. That's why we are getting electrocuted. But here the voltage is low, it's nothing to worry about. Well, you can see, look on the multimeter, I can go up to 17 volts just by touching the base. It will not happen if I touch the base of the big one. No, because the amplification is not enough. That's what I use the second transistor. So actually, to make everything this to be a very, here I can come with low signals and I can open both transistors. Hopefully it's clear. I know I'm bad on explaining things. What I want to do now, yeah, and that's simple. This is the base. I want a resistor from plus 35 to minus, yeah, a resistor, adjustable resistor, which is this one. That's what the reason why this has 3 pins. They all have 3 pins. So one is this, and the adjustable I want to go on the base. So here I will have 35 volts, 55 volts. Here I will have 0, and the middle I will be able to go with the voltage from 0 to plus 35 volts on the base of this transistor. That means my output will get changed from 0 to 35. That's on a paper. Actually, on the reality, the voltage will be lower, because I told you on the beginning, this 35 is just is not really usable. So let's use this. So the middle is the one which is moving on the. Actually, this is what is inside. It's a resistor. It's a carbon resistor, and it's a metal thing. It's moving on the resistor. So on the base, on the plus is collector also, so I can do something like that. Yeah. Yeah. Let's solder the thingy. Oh, it's plugged in, sorry. Let me unplug it. This base is too big here. Let me bend it. Okay, to plus. And one pin which has to go to minus. This pin is going to minus. That's me here. Okay, so I just add this one. Minus, one pin to minus, one pin is soldered to the collector of this one, the plus line, yeah, and the middle is going to the base. Now if I'll plug this in, so check here. Now already we have adjustable power supply from 0 to max voltage. Max voltage, which is 26 volts, you can see on the voltmeter. That's the power supply, it's adjustable. And you can change the voltage, like what voltage do you want? What do you think? So now we have adjustable, it's getting warm, adjustable power supply. It's working. If you have a big one, big knob, you can adjust the voltage. It's one problem with our power supply. Actually, let me show you what's the problem. Coming with the voltmeter, we don't need voltmeter. Let's open the loads, yeah. Let's raise the voltage. Let's say 20 volts. We have two light bulbs, 12 volts each. Now we have 20 volts. You can see that. If I will connect the light bulbs, look at the voltage, like 17. Why? You know what I mean? 20 volts connected, now it's 17. If I will be to check on the input, let's check on the input. Volts, ground, ground, and plus. You see, on the transformer right now, on the rectifier bridge, we have 32 volts. Okay, when I connect these two, we have 29. You can see on the multimeter, 29. So on this point, it will be only 29 volts. That's kind of normal. Yeah. So, like how I told you, when you come with a load, the voltage goes down on a transformer here. Yeah. But obviously, this will not work for us. So we have somehow to make this voltage more stable. Sorry, let me connect this too. Let me unplug it. Now the reason why this voltage is not stable is simple. Because the voltage on the base is from here. If this voltage goes down, yeah, it goes down, this voltage will goes down. So all what we need this voltage from here to be stable. If the voltage is stable here, will be stable here, and will be stable on the output. Yeah, So that's all what we need. We need somehow to use this voltage to be stable. If the voltage will be stable, this will be stable. Yeah? Even if you adjust it, but you adjust a stable voltage. Yeah? So we'll use on this case a Zener diode. Zener diode is beautiful. Yeah? A Zener diode can give us a stable voltage. I do have a lot of Zener diodes here, but you can do we have a 18 volts one, 1.8. You can do it on serial mode, 1.8 and 5 V6, yeah? So we can use two Zeners just to achieve the voltage what we want to get stabilized, yeah? To be our reference. The Zener diode, you can connect them on the serial mode. They are fine. Plus or minus, simple. Let me solder the diodes. So the diodes, it will actually set up the output, the max voltage output. Plus and minus. So okay, let's redesign our schematic. So I will not take the plus from here. I will get the plus. Plus, I will use a resistor to obviously lower the current, because otherwise I will burn the Zener diode. And here will be a Zener diode. On our case, we have two Zener diode because we don't have the final value. And from here, we can come to our adjustable resistor here. Yeah? And on this way, we will have a stable voltage here. Yeah? So let's solder this. Let's do it. So one has to go to ground. So this can be like that, to ground. And the plus will go. Yeah, let me find this resistor. So this I want to use around 400, 500 ohms, should be fine. Even more, let's say 1 kilo ohm, should be fine. Let me try to find a resistor. I have my box with twice. Yeah, 800 ohms should be perfect. Yeah. Let's see. Let me check the resistor first. Ohms. $600 ohms. Perfect. It's fine. So I will desolder what was before the adjustable resistor. I will desolder from here. Okay. And now I will use this resistor. Let me see how can I cut down this one. I have a nail clip here. Let's make it shorter. let's solder the resistor. So from plus, from plus 35, which is this one, the collector of the big transistor. The plus is coming here, you remember? So it has to go here on the end of the adjustable resistor and on the Zener diode. That's me here. Okay, so the Zener diode. These are too long. Let's short them. Plus. You know what? We can do it like that. Because the Zener diode is on the end of the adjustable. You see, these are soldered together. So it's in a parallel mode with our adjustable resistor. So it will be like that. Plus, pay attention on the plus and minus here. Plus here. Minus is going on the other pin. Here. It's a simple one. I told you, you can't have high expectation, but it will work exactly like buying a new one. Not be so, you know, it will work. It will do the job. So now we have stable voltage. We have a Zener. Let's check together. Yeah, let's check together. Let me lower the voltage because we don't care about this. So now if I come with the multimeter, yeah, multimeter minus on the plus of the Zener, diode, we have 26 volts. So whatever happened, that 26 will be there. So now if I will change the if I will change the output voltage, the ground is not touching from some reason. 26 volts. Okay, let's change the output. You can see it's quite stable on the voltmeter. Now it's not changing like how the output is changing. How the input, sorry. You remember last time on the input, on the plus 35 or 32, how much it was? When I was lighting up the bulbs, the voltage was going down. Now it's not the case because we have a Zener diode here. Okay, you can see the voltage. The voltage will be the same even if I will light up the bulbs will be the same. That's what the Zener diode are doing. Okay, so now our output voltage is quite stable. Now you can say, you know what, we do have something what is called a power supply. Yeah, so now our power is regulated. Okay, and it's stable. Whatever happened here, where when the with 220 is going up and down, no, my output voltage will be stable. That's very important. So that's the schematic right now. Now we have the both diodes together are like 25 volts. So our Zener is 25 volt Zener. 25 volts Zener diode. Yeah. If you don't have the right Zener diode and you have a Zener diode like that, you can use something like that. So let's say that's our Zener diode, and you have one Zener, but it's not enough. So you have to use one Zener. Not necessary. Depends. If you want like 2 volts output, you can use normal diodes. Yeah. Okay. So our zener, okay, is like that, and you can use the diodes on a serial mode with the zener, but like that. The diodes should be like that. And each diode, it will increase the primary zener value with 0.6. So 0.6 plus 0.6 plus this value. Okay? So the zener diode plus this. Or if you don't want to use a zener, use the diodes. So you have a lot, well, obviously you will have a lot of diodes. Like this, and each diode will be 0.6 volts. You can use 4148, which will be fine if you use the diodes. On a serial mode, okay, but you'll need a lot. So each diode will be 0.6 volts. You have 2 diodes, you use 1.2. If you have 4 diodes, it will be 2.4. The voltage is quite low. Okay? It's clear? Anyway, I will read the comments and I'll see what you didn't understand. Now we can go on the next video. Now we can adjust the voltage, and also the voltage, the output voltage, is stabilized. So whatever happened on the input with the input voltage, the output will be always the same. Will be always what I will set up from this adjustable resistor. The next is the current. So we finish with the voltage adjustable thing. So our main thing is the current. First, to check the current, we need an ammeter. Ammeter, you can connect it on a serial mode with the load. Yeah, with the load. So in our case, I will use ammeter, which is these 2 wires. I will use it on the output here. This will be my ammeter on a serial mode, serial, with the ground, because that's the configuration on this case, but can be on the plus, not this one. Yeah? So what I will do, I will desolder this, the load. Let me unplug it first. In this moment, no one is controlling the current. In this moment, if you short this will get a big, hit, because all the current will be here. The pressure will be here. It's not only here, it will be on transformer or a rectifier bridge on a transistor, but you have nothing here to limit the current. Okay? So we have somehow to control the current. How we can control the current? Changing the resistance. Yeah? That's the way how you can control the current. So a resistor, you limit the current, not the voltage, how many people they believe. No, you limit the current. And obviously, limiting the current, the voltage goes down. Because they are related. Voltage and current, they don't work separate. Okay. So I'll solder this. This is here with this. I'll not keep you long. All what we have will be to control the current. Control the current and adjust the current. Okay? So I just soldered this pin of the ammeter, and this, from the output of the ammeter, we have the output. We have actually the output, and it's going to the load. Yeah? And now we should be able to read the current. Yeah? That's what this thing is doing. Yeah? It's reading the current. This is not setting up nothing. They are just instruments. just displaying what will go through this wire. Yeah. Okay, let's raise the voltage, and we have to see the current is going up also. Check the current. Right now we have like 1 amp. Do you see? Look at the current. 2.4 amps. Well, we can't control the current. Actually, you see now the current is going down, and you think, okay, we are controlling the current. No, we are lowering the voltage. Yeah, obviously, you lower the voltage, the current goes down. Okay. So what we want to control the current. Maybe I want to be there, like, 10 volts, but I want to limit like 1 amp only. So I want 20 volts, and I want to be only 1 amp. Yeah. The easy way to control the current, we need a current sensor, like how you seen on the laptops, on a lot of power supplies. So we need a current sensor, current resistor. That's the name. What is actually is just a resistor, yeah. But any resistor connected on a serial mode. Let's draw the resistor. So I will connect the resistor here. Not here. Let's move the voltmeter. Let's move it from here. Yeah, let's move it. I will connect a resistor on a serial mode with the output. Yeah. On a serial mode with the output. Low ohms resistor, very low ohms resistor. And we still have the voltmeter. No, let's connect the voltmeter here. Okay, the voltmeter is the yellow wire from this toy, and I will come with a resistor. I think we have few resistor. This has to be, this will be a big watts resistor. I have 5 watts. Should be enough for what we are doing here, but on this case, probably I will use like a 10 watts resistor. 2 ohms. And 2 ohms. I have only 2 ohms. I will use 2 on a parallel mode. I think 1 ohm should be enough. Even 1 ohm is too high. Should be even less. So I'll connect on a parallel mode 2 resistors, because I want a lower value, and I don't have 1 ohm. This is 2 ohms. 2 ohms is too high. I'll explain why it's too high. Okay, let's connect the resistor on the serial with the load. You see, this is the load. The light bulbs are the load. From the emitter of the big transistor, from the emitter here, I connect the loads. Okay. The resistor, sorry, and now the load, the output. This is actually our output. Now, what will happen? You'll be surprised. You can be surprised. What will happen on the resistor? Here. So I'll connect the multimeter here on this resistor, on the ends of these resistors, and we will see the voltage what's going across of this resistor. Check the voltage. Yeah. So the voltage is on this resistor. If I increase the voltage, look what happened with the voltage on the resistor. So the voltage checked here. So that's what a current sensor or current resistor is doing, yeah? Because every time you see on the power supply, you have a current sensor or current resistor, a different name. Each one can call him how they want. But that's what he's doing, yeah? And from here you can get two wires. And you can go with the wires on a chip which can see the current. The voltage is rising on this resistor when the current goes up, okay? Obviously we are changing the voltage, but changing the voltage actually is changing the current, okay? And you can see on the resistor you have like 1.6 volts right now. Lowering the voltage, the current goes down, and the voltage on the resistor goes down, okay? It's simple. So what we can do, we can use this voltage, yeah? We can use the voltage from the resistor to open something, yeah, and limit the current. So what we can open with that small voltage, 1.6 volts, we can open a transistor. And I want to adjust this 1.6 from 0 to 1.6. So I will use another adjustable resistor from here to here. So now I can have on this output, I can have like from 0 to 1.6, true? This will go on the base of a transistor. But obviously, the condition this transistor to be open is to be 0.6 minimum, maximal. It's not. It's opening by current. So actually, the voltage on the base will be lower. So the base will be connected here, and this will be the emitter. It's another NPN transistor. The emitter will be here. So when the voltage is rising, obviously the potential difference will be here with minus here. No, minus here and plus here. So here the voltage will be lower. Lower voltage is on the emitter, higher voltage is on the base. That's how my transistor will get open. And to short the output with the base and lower the controlling the current, okay? So let's say we have high current on the output. This must be here on this side. High current, high voltage here. It will open this, and this will short my my reference voltage from here. Yeah? Yeah. Emitter, base, collector. And that's how we'll control the current. So when the current, I will adjust the current, the base will be shorted with the emitter. Yeah, that's what this transistor will do. It will short the emitter with the base. If you short the emitter with the base, yeah, the current, the resistance will go high, the current will go low. So let's do it. I will use a different transistor, but same. I'll use a BD139. Or let's use something else. We can use something else if you want. But if we use already the BD, we can use BD139. And this resistor, we have two ohms resistor. That means now it's 1 ohm. 1 ohm resistor, which is it's too high anyway. The adjustable thing should be even 100 ohms. 100 ohms, yeah. I said last time, but you know that values are not important. You can modify them, so are not so important. Let me find an adjustable 100 ohms resistors. 100 ohms, 101. That's 100 ohms. It's unplugged. It's unplugged. So what do we have to do here? We need the base and the emitter, the adjustable thing. Yeah, base and emitter. Okay. Let's solder this. That's how you can control the current. And it will work fine. It will work fine. So the base should be here on the mid, on the here. Okay. One on the emitter. I wish to have a close-up camera. Okay. And we have one pin more, which has to be here. Yeah. And the emitter, which is this, has to be here. That's fine. So the emitter, yeah, on the output. That's the emitter. But I'll use a wire, so I'll solder this bit from the adjustable thing here. And also my collector goes to the base here, to this one, yeah, this base, yeah. Yeah, okay. How can I do it? The collector goes there. Okay. And this will go here. That's great. That's fantastic. But we have to adjust the thingy. Yeah, that will be great. Now the collector to the base, yeah? Good. And all what we have left, we have this. Must be soldered here. Okay. And we need the emitter to connect the emitter to here, on after the 1 ohm resistor here. Okay. The emitter is this one from here. And I think we are ready. So everything is set up. All we have to do is to check if it's limiting the current. So let's plug. It's plugged. Let's raise the voltage. Raising the voltage. Okay, I think our current limit is working. Yes. You see, this is the current. So let's leave max. Let's go with the voltage up. Yeah. Now we have 17 volts, 2 amps. So if we'll be to limit the current, let's limit the current. Let's say 1 amp. And you said, sorry, no. You limit the voltage. You didn't limit the current. Yeah? Don't try to fool us. Was 17 volts, you limit the voltage. No, I limit the current. Yeah? So if I will open the load right now, yeah? If I will open the load, check the voltage. Check the voltage, yeah? This is a current limit. So again, you see it's a current limit. You see the light bulbs? It's a current limit. It's 1 amp current limit. If I take the light bulbs, it's 18. So we can control the current right now, yeah? I will leave the I will not touch the voltage. I will change the current. And I can set up right now like 2 amps. You see, that's a current limit. Okay? So it's working. Well, you will ask, sorry, we can short the thingy? Yeah, we can short them. Let me limit the current. Yeah, you see, we have 2 amps short. So it's 18 volts, 18 volts. When I will short, obviously the limit is 2 amps. The voltage goes down. You remember, that's how the people got tricked on the first video when I bought that power supply. They said, if I short this and the voltage goes down, we have a protection. We have a short circuit protection, which is wrong. We don't have any short circuit protection here. We have a current limit, which is 2 amps. Yes, I can change this limit. Let's go up to see. 3 amps, 4 amps, 5.5 amps. But I can't keep it too long because it's I can't even touch it right now. You really need a big heat sink. So you see the current, which can be driven by one big transistor, can be like over 5. It's not even full. It's not even full. But if I go up to 5 amps, I'm going over the manufacturer specification of the transformer. He said it's 3 amps. Yeah, probably I can go up. No with voltage. Sorry. No with voltage. With amps. 8 amps, 9 amps. Yeah. So check here. 8.8 amps. One transistor is beautiful. You can do. You can carry a lot of current, but obviously one more time, I feel I have to explain you. You need a big heatsink. This I can't even touch it. Okay? You know what? I will stop this video. But let me know. And if obviously on the next video, we'll do how we can control the fan based on the temperature. I don't have a fan. That's the problem. Probably I will do it on this video, but I don't have a fan. I have to get like a computer fan so we can build a fan controller based on the temperature, because many of the power supplies, like what I bought, the fan is spinning always the same, like same speed, and it's noisy. It's not nice. So we do have a current limit right now. Ay. These were two. I can adjust the current. Hopefully you can see. This is the current, what I'm adjusting right now. From high to low. Yeah, obviously the voltage is changing, because that's what a current limit is doing. But if I take the load, it's going up. It's going up or how much you set up. You can set up any value. Yeah. You have from this one, you adjust the voltage. So hopefully you can see what I did here. It's not a big it's hot. How can I do it? But I explain everything what I did and everything what I solder here. Yeah. It's nothing complicated. You have the schematic and you solder the bits. What I use here, this, it's a BD139. This is a BD139. And this was, I can't see on it. But you can use any. That I'm trying to explain. You think, now listen. You think instead of this resistor, which was like 600 ohms, yeah? 600 ohms. You think if I will use 1 kilo ohm or 400 ohms, something will change? No. Yeah, it will change. It will change the current flowing on this diode, Zener diode. But it will be fine. Because the Zener diode, you go up to 2 watts. This kind of Zener diode. So we have a lot of things, yeah? This adjustable thing. You think if I will use, like, let's say, on this, what we have, 10 kilo ohms, yeah? 10 kilo ohms, adjustable. You think if I will use 20 kilo ohms, it will change anything? Or if I will use 50 kilo ohms, you think it will change something? No, absolutely nothing. We have leverage. I know this word is used on the financial things, but I don't know how can I say. We have, you know, we can do it because that's the reason why you use two transistors here. Probably it will work only with one. Probably, I'm not sure. I don't know if it will work with only one transistor without this one, to take this out completely. You think if I will use a small transistor here and here it will not work? Yeah, it will work fine because here is not so much current. So you can use small transistor like this. You can use something like that. This is a small transistor. It's a BC, I think it's 109. It will work fine. Here and here, yeah, not here. Here you need a big one because that's the transistor who is doing the job. Is changing the resistance, yeah. Okay. Just let me know, just let me know in the comments. Even if it's a negative comment, it's fine. Just let me know what do you want to do more with this. What do we want to test? So, or how we can change it. We can do like complicated. We can complicate a little bit the problem. We can use some chips on this moment. Let's say I'm not using a current limit, yeah. So I am not using a current limit. So I will explain you the downside of this power supply. The downside. So we don't have a current limit, okay? So check here. How many volts do you have? 13, yeah? Now it's not current limit. I'm using a load with 1.7 volts, but we have only 12.2, 12.3. Why? Because my schematics doesn't have output feedback. So actually, when you see on the, unplug it. 12 volts, but when you connect the load, you have like minus 0.7, 0.8 volts less, because this is taken from the voltage from here, and he can't see the output, and I'm losing here some voltage because it's a transistor, it's a semiconductor. I'm losing a little bit on this 1 ohm resistor, yeah, and obviously on the output I will have, like on this case, like 0.7 minus. So this is a schematics without output feedback control. The feedback, the reference voltage we are getting from the input on this one, okay, and we are using a Zener diode to make it stable, but this is not supposed to be stable. It's supposed to be on a relationship with the output to compensate the losses on the transistor and the resistor. Anyway, this is just a basic schematic. It's a basic one. It will work, it will do the job exactly like buying a new one. It will do the job. But you see, it has small things, like you see that voltage drop. Yeah. Okay. So I'll stop now. I really need a coffee. Yeah, it's Sunday in the morning. It's 11 o'clock right now. It's raining badly outside. So I will go to have a coffee. Just let me know. You know, the part which you don't really understand, and I will explain, because I can do how many videos I want from home, and I can do how longer I want. So we can do a lot of things from here. Yeah, just let me know. Thank you for watching. Like and subscribe if you like the video, and see you on the next one next week. Yeah, bye.